For 20 years, there's been a killer living amongst us. Already, its victims are in the tens of millions and counting. It doesn't discriminate between color, race, or creed, between young, old, rich, or poor. Yet, most of us think we are not in danger. This program looks at the origins of AIDS, from transmission and symptoms to awareness, and how British scientists are working with scientists from around the world to find an effective long-term treatment. According to the United Nations, there is an estimated 40 million people living with HIV in the world today. Sub-Saharan Africa accounts for 70% of all infections. Added to this large number are the increasing prevalence rates amongst pregnant women.
I think it took up until last year for people to begin to see people actually dying. Because I think it was perceived as something that was happening elsewhere and not here.
I think the unique thing of the HIV epidemic is that people have come to realize that it is not an African problem only, it is definitely a world problem.
Although Western Europe accounts for only a fraction of the world's HIV sufferers, this year there are alarmingly large increases in the United Kingdom, Spain, and Portugal.
In the recent figures that came out, we saw a 17% increase on figures from last year to this year, and the majority of those new infections were amongst heterosexual people.
Eastern Europe and Central Asia accounts for 2.5% of the epidemic. This is now the largest growth area, with Russia experiencing a 1,000% increase of reported cases in the last 3 years.
In some countries, particularly in Eastern Europe, what we're seeing is an epidemic growing up around injecting drug use, so it does vary from place to place.
7% of infections are in the Americas, with most found in South America. North America has had relative success in keeping the numbers down. Recently, however, there have been large increases amongst women and homosexuals.
I think it's a very big deal, but we don't always think about it. We don't always see it all the time. We don't know who has it, so, it's not something that's in the news every day.
Yet, despite it being a global problem, stigma and ignorance continues to surround HIV and AIDS. This, in turn, is making the epidemic even greater.
I definitely expect it to get worse before it gets better.
HIV is a virus. It's the human immunodeficiency virus. It's a virus which is spread sexually and by blood products and sharing needles, and also vertically from mother to child. And once that infection actually gets in the body, it stays for the rest of your life.
But what is the origin of this world killer? The oldest evidence of HIV infection dates from 1959 and was found in stored African blood samples. HIV is thought to have been carried from Africa to Europe, the Caribbean, and the USA via guest workers and tourists during the 1960s. The first known case of AIDS, identified later from stored blood samples, was found in the USA in 1969. A Danish surgeon contracted pneumocystis carinii pneumonia while working in the Democratic Republic of Congo. She returned to Denmark and died in September 1977, and was later recognized as Europe's first case of AIDS. In July 1981, the New York Times reported an outbreak of a rare form of cancer among gay men in New York and California.
I've covered AIDS for more than 20 years. I wrote one of the very first stories about AIDS, which didn't have a name at the time. It was a story about 41 gay men who had a type of cancer called Kaposi sarcoma, and that was a rare cancer at that time, and it appeared suddenly in New York, particularly in gay men, and nobody understood why this group was affected and why it was occurring at this time. Nobody knew what to make of it at the time because they were relatively small numbers of cases. It was scary from the point of view that something new was happening and nobody could understand it. Didn't seem like a threat to the entire world or the country at that time.
In 1982, the Centre for Disease Control linked the illness to blood and coined the term AIDS, standing for Acquired Immune Deficiency Syndrome. A year later, a detailed description of HIV, the virus that causes AIDS, was made by Dr. Luc Montagnier of the Pasteur Institute and Dr. Robert Gallo of the National Cancer Institute. Humans, as with all animals, have a basic need to mate. Unlike most other animals, however, we also have sex for pleasure, rather than just for reproduction. Blood is an essential part of our bodies. It travels via a highly efficient transport service provided by blood vessels and powered by the heart. Our blood contains numerous red cells, which carry oxygen, and fewer white cells, which defend the body from infection. In addition, they clean up the body by eating everything that is in the wrong place, like dead cells. The surface of internal parts of the body that have contact with food, like the mouth and guts, is lined by a soft, red, damp layer called the mucous membrane. It is also found in the vagina and anus. This layer is much more delicate than skin and can be damaged easily. If there is a break in the mucous membrane, blood flow to the area increases. This in turn increases the number of white blood cells at the site, rushing to eat up any germs and foreign matter, causing inflammation. Squadrons of white blood cells arrive at the scene and surround the intruder. When the HIV virus is present, the white blood cells unwittingly play right into its hands, as they are the very cells that it is targeting. The outside layer of the HIV virus contains a special protein that will bind onto waiting receptors found on the white blood cell. Once attached, the HIV virus empties itself into the cell's body. It wastes no time instructing it to produce new HIV viruses. Now, the white blood cell has been hijacked. It takes less than a day before the newly infected white blood cells begin to mass produce new HIV. Each infected cell will produce thousands of HIV before dying. It will take between 6 weeks and 3 months of contracting the virus before antibodies can be detected on HIV tests. Within a couple of months, if untreated, 1,000 billion new HIV may be produced each day. A person is said to have AIDS when their immune system has finally been overcome. But on the surface, everything may seem deceptively fine.
Clinically, when someone is infected with HIV, initially nothing happens. It's like any disease. Once you catch it, it takes a while for the body to react. And once that infection actually gets in the body, it stays for the rest of your life, and it swims around causing problems with the immune system and actually attacking the CD4 cells which bear a specific receptor called CD4, which are basically needed for the immune system to work properly. And as the CD4 count falls, which may take many years, then the individual is more likely to develop infections and tumours. In around 75% of people, they will develop a seroconversion illness. That's when the immune system starts to fight HIV, and at that time the patient may become unwell. They tend to get very flu-like symptoms, may develop a skin rash, feel generally unwell, but it's a very severe flu. It's a very important time because treatment during that period may actually prevent, well not prevent, but slow destruction of the immune system in the future.
People who are infected with HIV do not truly die of HIV infection. They die of opportunistic diseases like tuberculosis, pneumocystis, other kinds of devastating diseases, sometimes of tumours. And they die of those diseases because they have become immunosuppressed, because their immune systems are no longer working really very well at all. So other bugs and tumours and so on and so forth can take hold and kill.
Other than abstinence, using condoms during sex remains the safest way of avoiding infection of any sexually transmitted disease. But this simple fact is not always getting through.
You have to sell prevention like you were selling Coca-Cola. You can't just inform people. You have to hit them over the head with it and continually remind them.
What we're seeing is a rise in all sexually transmitted infections amongst young heterosexual people, and that means that HIV infection is also going to be taking place. If somebody's going to have penetrative sex, then the only way to stop HIV passing from one person to another is to have a barrier in the way, in between. And a condom is the most effective way of doing that.
We should be able to convince people how not to get infected, because we know that. This is not a mysterious disease, because we know how it's transmitted. We know how not to get infected. What could be simpler?
The advances in antiretroviral therapy have given some young people the sense that AIDS is not as serious as it was 20 years ago. Many people have mistakenly seen the advances in medical treatment as tantamount to a cure. In hospitals and research laboratories in Britain and around the world, work has been underway to find the best treatments for this growing epidemic. Now, almost 20 years after the science world took up the HIV battle, much ground has been made.
15 years ago, I'd be attending funerals probably at least once or twice a month. What I'm seeing now is that I'm actually supporting friends to live with HIV. And so that experience has changed.
Many believe that the new drugs are a cure. They are not. They may be working, but at a cost.
We know we have drugs. They're not perfect drugs. They're highly toxic, or they can be highly toxic. They're difficult to take.
The problem with only giving one drug is resistance. The virus is very clever at changing so that the drugs don't work. So if you just give one drug, it's very easy for the virus to make the changes necessary. If you give 3 drugs, it's very difficult to make all the changes necessary for all the drugs to stop working.
I think people tend to think these drugs are sort of like taking an aspirin every day and very simple and everybody will get better. And of course this is not the case. These are difficult drugs to take. They're very, very expensive, and they do have quite nasty side effects in many cases.
The nucleosides can be associated with anemia, peripheral neuropathy, which is loss of feeling in the feet. The non-nucleosides are associated with hepatitis, inflammation of the liver, and also with neurological side effects such as very vivid dreams, perhaps a little anxiety. And the protease inhibitors can cause diarrhea, kidney stones, nausea. And then all the drugs together have also been associated with changes in fat distribution, so that people developing thin arms, thin legs, perhaps thin faces, large abdomens, and also with high rates of raised cholesterol, raised triglycerides in the blood. So these aren't nice drugs. No one would choose to take them if they didn't have to, but they do save lives.
But drugs are not an option in many parts of the world, as developing countries are struggling to supply affordable HIV medication.
We need a global initiative, obviously, to bring these drugs to as many people who are already infected with HIV as possible.
You have a situation where the annual GDP is what, $100 per capita? you definitely cannot afford it. So what you have now is most of the people who are using antiretrovirals are getting it from relations who are working outside, and then they are bringing it in combinations that are not necessarily good, and you don't have trained physicians to actually monitor.
British scientist Professor Andrew McMichael is head of the Oxford AIDS Vaccine Initiative and is at the forefront of vaccine research.
I've been doing this research for about 25 years, before AIDS was ever heard of, or HIV was ever heard of, or noticed clinically. There is, I think, a swell of research coming towards trying to use the immune response as well as drugs. So, in other words, to mix vaccines and drugs in some way to treat people. Well, a cure's probably a bit far out, but a long-term control of the infection without drugs, I think, is a realistic aim. And I say that because we're all infected with certain viruses that we control without those viruses causing us harm. So there's a virus called Epstein-Barr virus, which is the cause of infectious mononucleosis or glandular fever, also causes some cancers actually, that something like 90% of the adult population in this country and most countries are infected with. And once the initial infection is brought under control, we're fine. And we have that virus on board, but we have a strong immune response for life that controls that infection. So if we could get to that situation with HIV, I think we more or less have cracked the problem. The vaccines we've all received for measles and mumps and smallpox, if we're that old, they're all designed to stimulate antibodies, which are small proteins, which stick onto the virus, and they prevent the virus infecting cells. This approach, which has been so successful for many other viruses, is not working for HIV. It's not been possible to stimulate that kind of antibody with a vaccine. So we're looking at an alternative route, which is to stimulate what we call killer T cells. And these are the cells in the blood that normally get rid of virus infections. And so the idea is we have these waiting when the virus invades, and they will then get rid of the virus before it really establishes an infection. I think one of the big problems with HIV is its variability and its ability to mutate. And by mutation, it can escape the immune responses that would otherwise control it. And I think this is a major feature of the infection. I think this is going on all the time in people who initially control the infection but later succumb to AIDS, and that's virtually everybody infected without treatment. We have to design our vaccine to get the best match to the virus strain that's in that part of the world.
We have now come to understand that the type of the virus that is circulating in Ethiopia is predominantly of the subtype C virus, which is also common in other countries such as South Africa and also India. We want to know the molecular epidemiology of the virus in Ethiopia because now we are in a preparation to engage in vaccine research. So having this information is a very important background for whatsoever action that we are going to take in the future.
We have designed a vaccine, and it's a vaccine that's aimed at Kenya and East Africa. It's that particular subtype of the virus. And the vaccine we've put into human trials, clinical trials, in people at low risk for HIV infection initially. And the first results are looking encouraging. So it's looking safe so far on preliminary analysis. And the first analysis of the results shows that some of the people who received the vaccine are making immune responses.
HIV/AIDS is a big problem in this country. About 700 people are infected every day. Any volunteer who comes here before they are recruited into the study, they meet the nurse counselors who go through various issues of concern for the study.
This vaccine is on trial, and you're looking at the safety issues. We do not know yet whether it protects or not.
At the same time as we do the trial, we have to give them all the best advice to encourage them not to get infected. So we have to give them access to condoms. We have to give them all the information they need to avoid infection. So these trials are going to be really complicated to do, and they have to be done on a huge scale, and they have to be done in communities where there's a high level of infection. So we have a lot of talking to do to those communities before we can start.
After the volunteer has been counseled by the counselor in the other room, they come here for confirmation that the information they were given has been properly understood. And the second counsellor goes through what we call assessment of understanding.
The vaccine itself is not HIV, and it cannot cause AIDS, it cannot cause HIV infection, so it's actually, in that sense, quite safe.
Mr. Kazungu, now we are ready to inject you with the product, the vaccine. On this, your left arm, it will hurt a little bit.
But it will not be painful.
Okay.
This vaccine, when given, is supposed to then make the body stimulate the production of this, what we call cytotoxic T lymphocytes. This is a subsection of the white blood cells, which are meant to fight infections. And these cytotoxic T lymphocytes are thought to be the ones that really target the HIV virus.
How do you feel?
It is my feeling that a vaccine is the eventual answer to this pandemic, a vaccine which would protect everybody in the world.
A long-term control of the infection without drugs, I think, is a realistic aim. Perhaps I'm being very optimistic, but I think that is something that might be achievable within 5 to 10 years.
We have 40,000 new infections every year in the United States that have remained level over the past few years, and we have dramatically rising infection rates among gay men of color and young gay men. If you're an African-American woman, you're 12 times more likely to be HIV positive than your counterpart of European descent. Yet there are countries like Senegal, Thailand, Uganda that with limited resources have been able to dramatically decrease their HIV infection rate. So it's not a question of resources, it's a question of willpower and political commitment.
If you see the awareness and compare it to the past few years, everybody knows about HIV. Everybody also knows how it's transmitted. But to bring about the change in behavior, we need to work much more harder.
Up until maybe 2 years ago, you would not under any circumstance find one person who would come out publicly to say that they are living with the virus. Nobody spoke about it. You didn't hear anything on the radio, on television about HIV/AIDS. You don't even hear the word. Now it's completely different. Every single day, there are a lot of messages on the radio. There's drama, there's music, there's news. They're bringing a lot of information from what is happening outside. The school children are getting energized. Anti-AIDS clubs have been set up throughout the country.
I have worked in Uganda for 10 years. And Uganda, during that time, has successfully held the pandemic of HIV at bay. This has been done primarily through education and openness about the disease. There has not been any stigma attached to the disease, or very, very little. It's very common every day to see quite what we would perhaps consider quite controversial news items in the papers. On the television, there's continual short cartoons and so on and so forth to encourage safe sex.
In recent years, Uganda, Senegal, and other African nations have increased safe sex and HIV awareness to their young by being upfront and by employing innovative methods to get the message across.
Ladies and gentlemen, the march is getting very exciting and highly interesting. This is a program march in commemoration of the World AIDS Day.
Although some countries have taken on the epidemic head first, the world's battle against HIV is still raging, with millions dead and dying.
I'm very optimistic that there is hope for the future, for the young, but we need to work much more harder.
It's a massive issue, and it's something that really we can only tackle with countries working together. We need to view this as a global problem. It's something that we have to deal with, and we have to deal with effectively and strategically.